Thank you, Christina. All right. Thank you very much. So appreciate you guys coming out this afternoon. So as Christina said, I'm Jason Noble. I'm the Associate Manager for NASA's White Sands Test Facility. And so for the kids that are in the audience, how many of you like space? Excellent. How many of you want to be an astronaut when you grow up? No one wants to be an astronaut when you grow up? There you go. Okay, good. Excellent. So this first robotics competition that you all are a part of and gathering information for is a really cool opportunity related to everything that NASA does, because the challenge that you're facing in this particular competition is very much what we do out at the White Sands Test Facility. As part of your competition, you're looking at the issues that NASA has to deal with and the astronauts have to deal with on a daily basis for any sort of missions that are coming up. And within your lifetime, you're for sure going to see people walking on Mars, and that's pretty exciting. So, and for anybody that wants to be the astronaut, that could be you. So, pretty exciting. But anyway, so White Sands Test Facility, as you're driving out, like you're going over towards Alamogordo, towards the National Monument, is just on this side of the mountain. And one of the things that we do for the space program it's very focused on keeping the astronauts safe. And some of our main focus areas are the rocket propulsion systems, and we make sure that those operate properly. And then we also do a lot of materials testing, and a lot of the things that you'll see in the room are related to the materials and how things react when they get into space. And that's real important to keep the astronauts safe. And so, and then another talk that you'll hear today is about, there's a lot of debris in space that's traveling at really fast speeds, and how we protect the astronauts, how we protect our spaceships, and how we protect everything associated with those, and the shielding that's used is another piece of information that you'll get to learn about today. And so White Sands Test Facility tests all that stuff for NASA, and with the focus of really keeping astronauts safe when they fly into space and they journey onto either the space station right now or then onto Mars. And so, what's that? What is the space station? So the space station is a orbiting laboratory, an orbiting spaceship that goes around the Earth out in space at about 250 miles straight up into the sky, and goes around the Earth about 21, 23 times every day. Okay, what? You're scared of outer space? Well, see, part of not being scared of outer space is all the testing that we do and everything to keep our astronauts safe, so that there's nothing to be scared of. So anyway, so I just wanted to thank everybody for coming out and on a lovely Saturday afternoon and learning some more about NASA and learning more about the first robotics competition and gathering information from all of the presenters that you'll see here today. So appreciate it, and I'm going to turn it over to Don Henderson, who's going to talk to you about the hypervelocity impact testing that White Sands does, which is related to the shielding of all the particles that they might come across. So thank you very much, and I'll turn it over to Don.
So one of the things that we're going to have to worry about when we go to Mars, or anytime we go into space, is debris that's out in space. You've probably heard stories, and there was a recent one a couple of weeks ago where a Russian module got impacted and there was a hole in it. They repaired it with a piece of tape, and yeah.
I read it online, and they fixed it with duct tape and epoxy.
Isn't that cool?
Yeah.
So they fixed it, but it was a small hole, but it tells you the space station gets hit on an average of about 16 times a day by debris out in space. So that's a lot of impacts, right? Just to let you know, there's about 20,000 objects in space that are about the size of a softball and larger, and those are tracked full time so that we can avoid them when we're out there. There's There's about 1.5 million pieces of space debris that are about the size of a marble and smaller. So there's a lot of debris out there. And chances are, if you're going to Mars, you're not going to be cruising around in low Earth orbit, but you're going to be going through that debris. So you're going to have to shield your spacecraft from debris. Now, you have to shield the windows sometimes or have multiple panes of windows. This is a piece of shuttle window that they use. It's about 1/2 inch thick, a few silica, but they use about 5 layers of it to make sure that the astronauts are protected. That adds a lot of weight, but at least they're protected. Another thing they use are composite overwrapped pressure vessels, and this is a graphite string basically that they put glue on and wrap around these vessels to make them very, very strong, but also light. So you have to protect these too, because if this gets impacted, it can either burst, so it's like a piece of dynamite on your spacecraft, or it's going to jet and push your spacecraft off course somewhere. Now, fortunately, in space, I say fortunately, a lot of people call the debris that's out there space junk, and I don't really like that term because we're out there exploring, and to me, it's accidental debris that we've left out there, but it's traveling at about 10 kilometers per second, which is about 22,000 miles per hour, which is about 10 times faster than a rifle on Earth can travel. Most of the falling stars that you see are actually pieces of debris coming back and burning up in the atmosphere. So this debris is traveling very quickly, but in a way that's a fortunate thing, because if you guys know the kinetic energy formula 1/2 mv squared, v is for velocity, it's squared, and so it's a very high factor in that equation, and the velocity is 22,000 miles per hour, so it's very, very fast, and you deposit all that energy in one spot on your spacecraft, it can do a lot of damage. That's actually a debris impact from about a 1-inch sized particle, so about as big as this. Did that much damage. And that's a big chunk of metal, right? That's 3 inches thick, it's about 50 pounds. That would be a hard thing to put on a spacecraft. So it's not very effective, right? But because the debris is traveling so fast, you can use something a little lighter like this. I can pick up with one hand. You just have multiple layers and you can absorb the impact. So when you design your spacecraft, you need to think about these things so that it doesn't make it scary for when you're in space and you can protect the astronauts. So anybody have any other questions? Yes?
Can you turn that one big block of metal around so we can see?
Sure, yeah. So the projectile came this direction, and this is what it looks like on the back.
Wow.
So.
I've seen some of those before.
Have you? You, sir.
It's not much of a question, it's more of an idea. It's how likely would it be that you could use shining materials on your spacecraft so that it would reflect the light from the sun and kind of do what the atmosphere does to the projectiles coming at your spaceship?
Maybe start burning up the projectile before it got there?
Yeah.
It's a possibility. We'll have to look into that. Good idea. Gregory.
What black hole inside a black hole and what do you look like? And why do you kill them?
Yeah.
What is a black hole and what's inside a black hole and what does it look like and why does it tear things apart?
Okay, that's outside my experience, my expertise. We'll talk later though. Yeah.
Why do you use several panes of glass instead of just one big one?
Oh, that's a really good question. Because the shock wave will travel through a thick piece. So when it's a single layer like this, the shock wave will end at the back pane of the glass. If it was really thick, that shock wave would keep on going through all the whole piece of glass. And in fact, I have another example over there that I'll pull out after my speech is done, that I can show you what will happen when it travels through a thick piece. Good question.
What was his question?
Sorry. His question was, why do they use multiple layers of glass instead of one thick piece of glass? Really good question. Aiden.
Why can't you just build a space shuttle or whatever out of diamonds? 'Cause
Okay, his question was, why can't you build a spacecraft out of diamonds? Because it would resist these impacts, which is a good question. It would be cool if we could, but it would be kind of expensive probably. And then diamonds are hard to form into the structure that we would need. So, yes, Silas.
I was wondering how many other ways of getting electricity on the ship do you have other than solar?
That's another good question. So some of the ways I know about are a tether that they string out for a couple of miles into space that will travel along with the spacecraft. And the tether actually is conductive, and it will absorb, or it'll attract ions which can be converted into electricity. Another way that is actually very effective, but it's not politically acceptable sometimes, is nuclear power is used on spacecraft sometimes. So, yes, Rose?
Something that would go with this question is perhaps, I know that people in space have to constantly get exercise to help keep their body in shape.
Mm-hmm.
And it has to happen more often here on Earth because our bodies are built for air pressure and gravity. And there isn't that up in space. So perhaps you could take the power from, you could convert the power from them on treadmills and, exercise bikes and convert that. It wouldn't be very effective, but it would be something.
Yeah, and they might be looking into that. I'm not sure. That's a good point. Yes.
Why do they have to have the tether so long instead of just keeping it?
Because it has to collect a lot of the ions from out in space to make even a little bit of electricity. But the ProSEDS rocket actually does that to create some of its electricity. Okay. One other thing I wanted to talk about is how long is low Earth orbit? Because it seems like it's just right around the Earth and maybe 250 kilometers into space or so, but it actually extends 1,242 miles into space. So over 1,000 miles into space is considered low Earth orbit. So that's a long way to travel through space on your way out. So your probability of getting hit by a piece of debris goes up the longer you're in LEO. So, any questions? I'm going to turn it over to John Tilka.
How's it going, everybody? My name is John Tilka. I'm a NASA engineer, and my specialty is oxygen systems. But first, I wanted to ask how many people were in the robotics teams here? Okay, awesome. There's a lot of you. I wanted to tell you that when I was in high school, I actually did the robotics team just like you guys are doing right now. And I just want to let you know that if you're really passionate about engineering, science, math, you guys are the people that are going to be solving the world's most challenging problems. And so I want to encourage you to pursue a career in solving those problems, like energy or space travel or biology or medicine, the things that you find really interesting, because we need those ideas and to make the world go round. So for oxygen systems, how many people know how much oxygen there is in the atmosphere? Yeah.
Around 29.7%?
You're close. It's 20.9%. So we say about 21%. And we need it for lots of important things, like staying alive, and we use it a lot for burning things, like campfires. You have a fuel like the wood, and it uses the oxygen in the atmosphere to burn and make heat. Can anybody think of some other places that we use combustion to do useful things? Yeah, flamethrowers. When you have a lot of weeds in your yard, you can use those.
The barbecue grill.
Yeah, a barbecue grill or a stove inside your house. And I'll just take one more.
Your car?
Yeah, your car. So we use oxygen from the atmosphere to do a lot of useful things. And when you're in space, you need to use oxygen to do useful things just like we do on Earth. Like we need oxygen inside the capsule or the space station in order to keep the astronauts alive and breathing. We also need it to use in our rockets because we have to get our objects going really, really fast to get up to the space station, about 17,500 miles an hour. That's 5 miles every second. So we need to use fuel like rocket propellant, kerosene, hydrogen, and liquid oxygen in order to get our rockets going really fast. And so, but there's a problem. Do you guys know what happens when you have high concentrations of oxygen? What happens to fuels?
They burn up.
They burn really well. Is anybody familiar with the fire triangle?
Yeah, you need fuel, oxygen,
And an ignition source. That's right. So I'm going to do a little demonstration for you here that shows what happens when you put fuel that's burning inside a high concentration of oxygen. So let me just put on some safety equipment here. It's important whenever you do an experiment that you think about what can go wrong and you have all the stuff to keep you safe. So does anybody know what hydrogen peroxide is? Sometimes does your mom use it when you have a cut to clean it up? So it's a disinfectant. But so hydrogen peroxide is 2 oxygens and 2 hydrogens, and it's very unstable. It wants to be water and oxygen. So we can actually make that happen pretty quickly with just a little bit of peroxide. And then we need a catalyst to make it break down into water and oxygen. And so we'll use yeast for our catalyst today. Just a little bit. If you put a lot, it gets really foamy and it goes everywhere. So hold on one second. Okay, so let's get this bubbling here. You can see our reactions happening pretty well. All those little bubbles that are starting to form there are oxygen. So we'll let that settle down. How many of you guys like to do experiments with your parents? Yeah, it's pretty fun. You can learn a lot doing science. Okay, so there you go. You might not be able to see the steam that's coming out of there. When you mix the yeast with the hydrogen peroxide, it gets pretty hot. So now we're going to take, now we've got all the things in our fire triangle. We've got the oxygen inside the container. We've got the wood, which is going to be our fuel. And we've got an ignition source, which is the matchstick head. So we're going to start the reaction here. So you can see this is a pretty standard flame. It's about what you'd expect from like a campfire. So watch what happens when we put it into a high concentration of oxygen. It starts to burn really, really well. So put that in there. So you might think about things burning really well in our atmosphere, but when we go into space, we need to take a lot of oxygen, and so it has to be at very high pressure. And the problem is that when we have really, really high pressure oxygen, things that we don't normally think of as being flammable become extremely flammable. This is a valve that is used to contain the oxygen on just a regular system. But you can see the metal is extremely consumed here. We started a fire inside of this valve, and it burned the metal super well. And so we have to do testing at white sands to make sure that we pick materials that are really good and flame resistant and oxygen so that we can keep the systems from burning up in space and on the ground. So I'll give you an example here of one of the ignition mechanisms. When you have, when you're starting fires in regular atmosphere, you need a lot of energy, and there's only particular ways you can start it. You need like a match or an electrical arc. But when you have an oxygen system, things that can start it on fire are maybe something that you wouldn't expect. Does anybody know what happens when you compress gas? Does it get hotter or colder?
Hotter.
It gets hotter. And so when, when the gas gets hot, it can get so hot that it can start the materials on fire. Right here, what I have is called a fire piston. What it has, I put a little teeny tiny piece of cotton in the bottom before I got started. And I've got a piston where I can compress that volume of gas in here a lot. And so we have some oxygen from the atmosphere in here, just regular 21%. But what I'm going to do is press on this very quickly, and we'll see if we can ignite the cotton in the bottom of the tube. So. So this is a little. Okay, you guys ready? Can everybody see that? Yeah, so we have to make sure that we make all of our oxygen systems so that we eliminate all of those different types of ignition sources. And that's what I do. I start fires for a living. So,
That must be so fun.
professional pyromaniac, if you will. Okay. Okay, yeah, so then I'll pass it on to the next speaker.
All right, thanks, John. My name is Damon Ogden. I'm a mechanical engineer out at White Sands Test Facility, and I work in the propulsion department. So propulsion department, people think, well, rocket engines, right? But a lot of what we have to do, what's been mentioned before, is dealing with safety and safety challenges that we have every day. So a little bit of background. We have to keep people safe while they're in space, but here on the ground, how do you stay safe in the car? Go ahead. Seat belts are good. What else is a good safety?
Some will absorb the impact from when you hit the other car.
Right. So crumple zones and airbags and whatnot, yeah. And then moving up in the atmosphere, we have airplanes, right? So what's a good thing to keep people safe in an airplane? Go ahead. Parachutes. And think of anything else that people use?
Air mask.
An air mask, so they can keep breathing. That's always good.
Good pilots.
The good pilots, definitely. Do you have one?
Well, it's just in the car, there's also a bumper.
Yeah, right, a bumper to absorb the energy, exactly. So some military aircraft also have ejector seats. So the people can get away from the craft really fast and make sure that they're okay. So we face the similar things in space, the safety, trying to make sure people get back on the ground safely. What we used to have was the space shuttle, and it didn't really have escape pods like you would see in science fiction movies. It didn't have a way to really get people away from the shuttle. So what companies are doing now and what NASA's doing now is implementing more safety precautions to make sure that the astronauts can get home safely to their family. And so what we came up with a few ideas and a few methods, and one of the really good ones is just add more rockets. Because if you can get away from something bad that's happening, then you're not where the bad things are happening. So for instance, the few models that are out there use very high thrust rocket engines that are attached next to where the astronauts are so that they can get away from any big problem that's happening near them. And it's a good method because you not only get away from anything that's happening if you're at the ground still, but also if you're in flight, you can get away from anything that'll happen. So what I'm testing currently, and my challenges day to day, is how do we get this safety measure safe? Because it doesn't just start safe, you have to figure out how it works, right? You have to engineer and design it. But there's a few questions. Not only do you need people who understand what a rocket engine is, but where do you put the rocket engine? Well, you need a space to contain it, to make sure you can test it safely. You need to make sure that you have systems that can feed the rocket engine with all of its fuels and cooling systems. And you also need to make sure that the rocket engine is performing well, so you can mount it on thrust measurement systems or sensors so they can tell how well the engine is actually performing. The thing on a day-to-day basis, that's the overall challenge, is to make sure that you stay as a team and that you have to act as a team. So when we have many parts out at White Sands Test Facility. We're all from different locations on the site, and so when I have an issue, no matter if it's big, small, Lego robot, rover on Mars, or spaceship, you have to know what the problem is, right? If you don't know what the problem is, you don't know how to solve it. Then you have to find out a plan, and then you have to see if you have enough materials. I mean, if you don't have a Lego kit, you can't build a Lego robot, right? The other thing you need to make sure that you can do is to accomplish your task safely. So that means using proper safety equipment. John used the gloves and the goggles to make sure that he was safe, and he knew that you all were safe because you were far enough away. Then we have enough time. You have schedules. When you have any engineering, any science project, it's always a schedule to make sure that you can get it done in time. And then obviously you have to make sure that you, as a team, always help each other out, because not one person is great at everything, right? I mean, some of us are good at a lot of things, and some of us are really good at that one thing. So you just got to make sure that the team is used very well, and you talk to each other, right? There's a lot of communication that goes on with teams. So, like I said, whether it's robots on the playing field on the arena, or rovers on Mars, spaceships going to Mars, or even tests out at White Sands, you have to make sure that teamwork makes a dream work. Just kidding. You got to work with your team. Make sure you communicate really well, and make sure that everyone stays safe and continues to do what they're passionate about, and that way you get the job done. Thanks. I'll hand it back over to Christina.
What would happen if you put something super heavy in space?
I didn't hear the question.
The question was, what would happen if you put something super heavy into space?
I'll take it.
The question was, what will happen if you put something heavy in space? And where we are normally used to working with heavy things, we don't have to lift anything in space, because you either have microgravity, very little weight, or you have zero. What would happen, though, is if you have this big mass, and astronauts run into this on the space station, is if you're moving a large mass and you try to stop it and got between something else, it would squash it. You can move something as big as a house, but if you try to stop it, there's a thing called inertia, and it will continue to push you. It's a really hard concept because we're used to gravity pushing us down, and these things don't push down on you. They're just there in mass.
How come condensation doesn't form in a space station?
I'm sorry, folks. I worked on space station for 10 years, so it actually does. Have you ever heard of the Mir Space Station? It's a better example of condensation. The Mir was a Russian spaceship. It was a space station. It was a lot smaller, and they would continually get rain on the outside or on the outside every day whenever the temperatures changed as it rotated. And what happens is we get condensation. We try to put fans in the space station. If you look at the space station, there's a little bitty one up there. We have fans blowing behind all that to pick the water up, but we will get condensation, and the astronauts have to go around and mop it up if they have a certain area that pulls the moisture out of there.
I've seen a lot of videos and things on the subject. So things like if the sun stopped burning or if the earth stopped spinning. But what kind of things would cause those to happen?
Sugar's going to be our star.
If you think about that, it would be such a catastrophic event. It would be like our sun going nova or something like that. And if you look at nature, we study this. Our astronomers study this every day. It's like no chance for that to happen in your lifetime or my lifetime. It's billions of years down the road. So any event like that is very, very significant. Now, in that category of things, we've talked about meteors hitting the Earth and the dinosaurs dying. You may have read about that. There are occasions we watch for meteors coming close to the Earth because that would be very catastrophic, and it's more realistic than the Earth stopping spinning.
How do bacteria behave in space?
Bacteria?
Bacteria. That's one of the issues. That's one of the 5 issues. For those of y'all that are doing the LEGO League, there's and the parents probably ought to remember this. There's a podcast called Houston, We Have a Podcast. And they have 5 10-minute sessions where they talk about the 5 different issues. One of the biggest issues that has the doctors at JSC worried is immunology, because when you're going deep space, your travel is anywhere from 9 months to 3 years. And if you get sick and pass it on to everybody else, it's a big problem. So as far as immunology goes, or getting a virus, I can answer that question in many ways. What we do today is we actually isolate the astronauts before they lift off, so that they're away from anybody that could give them a disease or a virus. And we try to keep viruses out of the spacecraft. We work very hard at that.
Okay. How heavy is an astronaut suit?
Is an astronaut's what?
Suit.
You could probably answer that. Right?
Can I? I can take a stab at it. Give you a break. All right, so an astronaut's spacesuit, they have a lot of equipment on there. So just the spacesuit itself has multiple layers on it, but it also has to have oxygen packs and everything else. So my understanding is, and you guys might know this better than I do, that it's around 300 pounds. Does that sound about right?
Apollo suits were the big white ones when they're EVA.
The big white ones when they're EVA, which means extra vehicular activity. When they go outside the space station, it's about 300 pounds.
Awesome.
How far away from a black hole do you have to be before it starts pulling you in?
I'm not sure any of us can answer that.
Yeah.
I'm going to attempt to talk to you about that. I just gave a presentation about how big the universe is to a group of high school students. It's probably hard for anybody in this room to conceive. A black hole basically would pull you in across a galaxy. It'll actually attract you. If you're asking how long could you live, we consider our solar system to be a standard measured unit. We'll call that a standard measured unit. You can't get any closer than millions and millions of the width of our solar system to a black hole without getting sucked in.
Okay.
Can you see a space station from a telescope?
See it from your naked eye.
Okay, so that's one of the fun things that my son and I like to do on camping trips is we'll go to a website called Heavens Above, and you can see what the orbit is of all the satellites around Earth, but in particular, you can see the space station with your naked eye on certain nights. And so if you go to heavensabove.com, you can find out when it's visible, and it happens maybe a couple times a month around here. So I encourage everybody to try to do that because it's really neat to see the big glow of the space station go overhead. You know that there's 6 astronauts and a couple of cosmonauts on there living. So that's a really neat thing to do. Yeah.
Do you need to have a rocket engine on in space, or can it be off?
I get a question.
That's a rocket scientist.
So the question was, do you need a rocket engine on while you're in space? Well, if you don't plan on changing the direction you're going, you actually don't need a rocket engine on because of, like Brent mentioned, there's inertia. So you'll keep going the same velocity in the direction that you were already going. And so on the International Space Station, they actually don't fire their rockets very often because it's just for minor adjustments to make sure that they stay in orbit. In order to get up to orbit is when you see the long rocket engine firings and burns like that. That's a good question.
Thank you.
My question is, where are all the girls?
You were supposed to bring them.
They were all busy.
There's one.
Yeah. So I am an engineer. I just putting the event together, so they want to speak also. But yeah, there are girls. Yeah. There are quite a good amount of girls in at White Sands, but you're right. There is still a high population of guys to girls, and that's why we encourage all you girls to keep studying science and bring along your friends that are girls and boys to study. There is often times when I will be the only girl in a room of 20 men, and it's important to recognize that. So thank you for bringing that up. Good job.
What would happen if you were to put food in space?
If you what?
Food in space.
Anybody know that one? Yeah.
He's our food smeller, in case y'all don't realize that.
Yeah, I've actually smelled food, part of the odor panel. I don't know if you came over to my stand, but I smell stuff before it goes into space to protect the astronauts from obnoxious odors. And so we have tested their food. A lot of times the astronauts will even get together and decide that they don't want some of the stinkier foods, like let's say fish. So they say, okay, we're not going to have any fish on this mission because it stinks to high heaven. And some people just can't stand the smell of fish in a confined space. So they are controlled by the calories they take per day. We have to do a toxicity. We have to do an odor test on them to make sure that they're not going to make anybody sick or nauseous in space. So that it goes through a lot of testing that you don't realize.
Hi.
Are we going to be learning about the International Space Station?
You're supposed to be learning about
Today?
As far as the Lego League, I've been kind enough to be invited to other areas. The International Space Station can be one of the problems that you choose. You're also allowed to choose deep space, which would be Mars and some of the other planets that we're going to go to in the future. So they're very applicable. You know, anywhere you're living in space, and in a space station, we have people on board all day, every day.
How essential is duct tape in space?
else to have it. Duct tape in space. Historically, duct tape has played a major role in space activities. If you watch Apollo 13, they have to make a CO2 scrubber, and one of the main things that they use to hold everything together is duct tape. And if you remember from my speech earlier, the impact that happened on the Russians' module on the space station, they repaired that with tape. So it can actually be very important. If you have to hold things together, tape is a good way to do it, and it's quick. So very important.
I have read about the CO2 thing on Apollo 13, that they made a duct tape bag and socks.
Yeah. Yep.
How do you dispose of waste in space from the bathroom?
I know some of it.
I know some of it.
I actually have a video on that.
You do?
Yeah.
Okay.
But it's
to be politically correct, you're talking about human waste, right?
Yes.
Well, right now, what we do on the space station, we hold it and bring it back. Okay. So it's a return flight item. In our future to Mars, there is a lot of discussion about whether we're going to be able to eject it or not. Do you know more about the Mars?
I don't know about Mars.
In the Mars program, they're actually considering getting approval to eject it off the spacecraft, but they haven't really come to terms with that yet. So it's a controversial item. You know something?
Let me add something to that. Here, the last few years, we're actually been testing an odor containment bag. And I don't know if you know this or not, but when the astronauts are out on their EVA, they wear adult diaper. Because if they have to go to the bathroom, they can't go 50 yards to the outhouse. So while they're out there for the 4, 5, 6 hours, they just got to do their business in the suit. Okay? So a lot of that stuff, like he said, is saved. So we put it into an odor containment bag. And we've tested several, and several have failed. So we actually have to analyze and smell test these odor containment bags. We had one for 18 days. It broke odor after 3 days, and we had to continue to smell it for 15 days after that. And it had a diaper full of feces. It had several diapers full of urine. And NASA has a recipe for homemade vomit. And that was in there also.
Thank you.
You're welcome.
I have 3 questions. What do you do with dead bodies in space?
What do you do with the body?
Dead bodies.
Oh, Lord. Okay, I actually have I have actually an interesting story about this. What we would probably do with a dead body in space is the mission commander would evaluate whether they leave them in space and not put anybody at risk going out to get them. If they were to pass away, and this is me listening to astronauts talk about the problem. If they were to pass away in the capsule, they would probably try to figure out a way to bag them and return with them, because they are their friends and they want to bring them back to Earth.
How would somebody feel if there was if they had a body in the refrigerator? How would the person feel as if they're saying, there's a dead person watching me, like a zombie?
Well, the astronauts are heroes, and they've actually been trained for high risk and high danger. And everyone I've known, and I've actually been fortunate enough to be friends with many of them, they've actually thought through this in their mind. You know, what would happen with their friends. So they would deal with it very well, I think, on orbit. Man, there's a lot of elements to that question, so I'll leave it there.
What if the relatives wanted the dead body back and you're somewhere far out in space? What would you do?
It would, there would be a big set of meetings to talk about whether what they should do with the body. But keep in mind the one thing, you guys are studying hazards in space and what people will deal with. And keep in mind that you do not want to put another person at risk to save a body to bring back. And so if there was ever something that happened where you were going to have to take a second astronaut and put them in hazard's way, we would not want to do that. Even if the family wanted them back, there would be, hopefully everybody would understand that that would be something that we do not want to do.
Would astronauts have to sign a paper that says, even if my relatives want my dead body back, I'll be let out into space?
You're a lawyer in Well, normally all the astronauts have gone through psychological training and discussion about their death in case, because it's a high-risk job. Like I said, they're heroes. And so most of them have come to terms with the fact they'll be out there, and they've talked to their families about this. And so I think that's all they've been dealt with. As far as laws and signing of papers, it's outside of my knowledge. Okay, that was 4 questions. Are you going to ask a 5th?
Yes, I have one more.
Okay.
How do you recycle dead bodies in space? Like, you use them?
There's no consideration for recycling a body in space. That would not be something that we would do. Too much respect for the person that passed away.
So even if you
6
need
questions.
plants, even if you need to grow plants in it to eat?
I'm sorry, I couldn't hear that very well.
Even if you needed to grow plants in the body?
No, that would be too disrespectful. We're either going to bring the body back, as you asked earlier, or we're going to have to leave them in their hazardous condition or wherever they were. Thank you.
If you're always breathing out oxygen in space, how do you make more?
That's a great question. So on the space station, we bring a whole lot of oxygen up with us whenever we bring a new rocket up to resupply the space station. But we can actually take water, just like I took the hydrogen peroxide and made it into oxygen. We can take water and break it into hydrogen and oxygen and use that. We try to reuse as much stuff as possible on the space station, recollecting water from all the different ways that we use it, and make sure we don't waste any.
Thank you.
Thank you.
How heavy is the International Space Station?
I used to know that.
And if you don't know the answers, you can jump to the website and we'll have extra.
Yeah, you can get on the website and we can get you that number. I dealt with each one of the modules separately, and when they were assembled together, they're totally different ways. So I don't have that number.
Okay.
We'll get back to you.
How big is the space station?
Okay, we have a picture of it back here if you guys want to take a moment later and look at it. Space station lengthwise, where the backbone is about 10 feet past the end zones, that back of the end zone of a football field. That's a pretty good way I describe it usually. And on the width, it is almost the length of a goal line to goal line football field. So it's like a rectangle, but it's almost square. It's very large.
That's amazing. Is there static electricity in space?
Static electricity in space. I'll give it a shot. You guys know anything about it?
He doesn't have the answer. Tell them to go to the website that's on the Science Around here.
Okay.
NASA Robotics first.
Okay. I don't know much about that, but yes, there can be static electricity in space, and we have to ground certain things like computers in the space station in order to not disrupt the electronic signals. And I do believe that they do have some on the outside as well of the space station, but we're going to do some research and get back to you on that on the website, okay?
How long does it take to fix a spaceship in space?
Yeah. Your question was, how long does it take to get a spaceship in space?
Fix.
Fix it.
Fix it. Fix it.
I'm sorry.
Fix it.
To fix a space station.
Spacewalks are 6 to 8 hours.
It's totally depends. It's like your car. Some things are simple, some things are more complicated. What came to mind when I finally could hear, and I apologize for my hearing, I'm not so good at hearing, is the Hubble Space Telescope was one of the most sophisticated fixes we did. And it took us, three days of solid workout in space. So that's the most complicated. The easiest fixes I've seen is probably a half a day, a few hours, because it takes us a while to get in our spacesuits and get outside and go fix something. I hope that answers it.
I have a number of questions. So my first question is, what if there was a large accident in deep space, say when we are attempting to, say, colonize Mars? Or like, if that would ever happen. Like, what if there was a large accident in deep space on the way to Mars? Something like the ship getting hit.
Even when you guys want to take it, I'll take it. If y'all don't want to take it, I've been up there somewhere. Okay. So for the rest of y'all, that's one of the issues that your LEGO league might need to be looking at, and if you have a large accident. If you haven't seen Apollo 13 and you're interested in this type of question, Apollo 13 would be an excellent video to watch. And what we would normally do is we would put a team together to figure out how to bring them back. And that would be the primary thing.
I have another one. So if, say, colonizing Mars is ever a thing that we try to do you think that having a large shuttle with almost like a colony of people and like a greenhouse and things on it, would that be a good idea, or would there be something better?
Well, it would be a good idea, but if you'll get on the internet, we've got a site, and we'll get you that information. You can take a look. You can ask the question, and have a dialogue with one of us, or maybe somebody at the site itself. But there are some ideas right now. There's a program called NextGen they're trying to deal with ideas that will allow the least amount of mass to have the most people colonize in a way to get to Mars.
Would having, say, a greenhouse or like a way of growing plants and having photosynthesis on a shuttle be a good idea? Like, would that be a smart thing to do? Like, what would the advantages of that be?
So actually right now on the International Space Station, they're doing experiments to grow plants in space, and actually they did some tests where they ate the plants that they grew on the space station. So people are looking into that, doing experiments about it right now on orbit.
Cool.
Something I should guys off. You guys have more than one question, go ahead and get back into the bottom, back in the line because we're running out of time.
Okay.
Thank you for all your questions though. You're great.
I don't know if anybody has asked this before because I just got here, but I'm wondering how you guys decontaminate ships when they land, or because when the Apollo 7 near when NASA was created, nobody made a big whoop about when they decontaminated, or no one explained how, if someone went out into space, how did they get back in without getting radiation sickness? Because space is full of it.
So I'll actually take that question. I work in Contamination Control, and so we haven't talked a lot about the radiation that they had to take off from space. but actually Apollo, all the dirt that they brought in from space was actually a very big problem. And it is something that they're looking at as to if they go to Mars and even if they go back to the moon, is to what their decontamination process will be. Because at one point, I can't remember which mission it was, but they were about to call it quits early because the pod on site was so full of floating dust. So basically, right, even though the moon has gravity, it's not that much. So once they got into back into their capsule, there was dust floating all over the place. So it was a problem. And so one of the ways they're looking at figuring that out in the future is making sure that the material they use does not attract it. So it goes back to like electrostatic, and making sure that the particles don't distribute on it. As far as radiation, I really don't know. Subject matter experts can be reached on the website, but that's the level of contamination I know for both Apollo and future missions is particle generation.
Well, I would suggest a material that isn't so magnetic because who knows what's out there.
All right, exactly. Thank you.
This is actually an answer to the kid that asked how heavy the space station was. We had a little pamphlet, and it said it's equal to 2.5 the whales, 6 space shuttles, 14 power sources, or 40 school buses. So it's really heavy. What are the effects of homesickness when you're in space?
Homesickness in space. That's like homesickness.
And the reason why I'm standing up is I've been working with a LEGO team, and this is one of the 5 issues. So it's a serious issue. And I'm going to combine homesickness with getting along with somebody in a tight space. So both of those are a big problem area. What we do today to keep that from happening is the astronauts go through a lot of tests. They go through tests to see if they're going to be able to work with others in emergencies or whenever everything's just really quiet for day after day after day. So they go through a lot of psychological testing. They have had some homesickness in the space station. And the way they dealt with it is the ground crew basically realized that the issue was happening, and they started a dialogue with that astronaut and continued to make sure that there was open dialogue and they knew what the state of mind of the individual was. And that's all you can do. You can't bring them back home. That's a good point. Point was made that they could Skype, and so they could see each other and actually talk to each other.
Thank you.
Okay, so how do you guys have to memorize everything, and have you done 30 years of college and everything? Are you guys the smartest people in the room all the time, or what?
No, I'm sorry. I can be the. These guys over here, they're brilliant because they went to college, okay? I didn't go to college, so I'm the dumbest of the ones up here, okay? I did go to high school, and I graduated high school. I had 2 years of high school chemistry and 4 years of mathematics, and that qualified me to be a chem lab technician, okay? And now I'm the highest paid chem lab technician out there. So NASA tries to bring on the brilliant ones, and somehow I slipped through.
Do you all have to memorize everything? That was the main point of my question.
Okay.
So, do we have to memorize everything? Thankfully, no. Big relief. What most engineers that I know in practice, there's a lot of source materials and technical standards that you know where they're at and where to find them. And then you can basically stand on giants to see farther, bigger challenges.
How do you prevent astronauts from getting sick in space?
Space sickness or sick in space?
Getting sick like having a cold.
A cold, okay. That has to do with the immune system, and we're really worried about that. So that's a big problem because even if you isolate the astronauts before they're getting on board, which is what they do, they try to isolate them and keep them in an isolated situation so they won't get sick. But viruses will last a long time. So what they try to do right now is whenever everybody gets on board, they have all the viral medicines and the essentials so that if somebody gets sick, they can isolate them on the board also. And that's the only way they can deal with it today.
Okay, thank you.
Yeah, thank you.
If someone gets sick in space, how long will it take them to get back to Earth?
Somebody gets sick in space, how long will it take them to get back to Earth? How far out?
Yeah. So the question was, if somebody gets sick in space, how long will it take to get back to Earth?
Yes.
Oh, well, it depends on where you're going and what you're doing. And so if you're right around Earth, it might be 3 or 4 months, maybe 6 months. But if you're deeper out in space, it could take longer than that. That's one of the challenges, major challenges with going to Mars, is because that's going to be about 2 years away in flight time. So if you get sick out there, you're going to have people that know medical protocol. Essentially, you're going to have doctors out there to help people heal, maybe. Or the astronauts are going to have to know a lot about how to heal. So, does that answer your question?
Yes.
Okay.
How often do you 3D print stuff in space?
So they're actually doing a lot of testing right now. They actually launched a 3D printer to the space station. There's a company called Made in Space that is working on developing ways that you can do different types of additive manufacturing. So the one, I can't remember what it's called, fused deposition. It's like the plastic wire that they melt and can make different shapes with. And so they're doing a lot of work right now to develop a way to print metals in space.
My dad actually has a 3D printer in his office, so I do think it's really useful because sometimes they print screws when we need them.
That's cool. Yeah, 3D printers are really handy because you can take a really generic material and make it into a whole bunch of different things. And they're actually looking at ways to recycle trash and make printer filament out of it. So they can recycle packaging from food and different things they have to bring with them and make it into a material that they can make something new out of. So.
Thank you.
They do have a 3D printer.
Is it illegal to throw a body into space? If so, why?
I'm going over all the space law stuff, I know. Man, I don't know. I'll tell you what, I'll look that up. I've dealt with space law before, but I've never heard anything about bodies and recovery. So I'll have to go look that up and get back to you.
Thank you.
Okay. This must be the problem. Further leg on it.
I have a couple of questions. Hypervelocity, right?
Yes.
So after the demo, my kid and I were talking in the car, wondering if you left the projectile out and just fired the gas towards, like, say, the side of the car or the back of the car, would it move the car or would it just, blast off?
Shoot a blank. Shoot a blank.
So you're saying if we have our guns that we fired these particles out of?
Projectile.
Just no projectile? The gases would push, but I'm not sure. It would probably maybe deform or dent a panel on the car, but it wouldn't. I don't think it would do much damage. It might depend on the type of gas. Normally we use hydrogen gas, and hydrogen gas tends to move around objects pretty easily because it's so light. Molecules are so small. If we fired a GN2 or something, it might be heavier. We might actually get more force out of that. That's a good question.
I was going to talk about it in the car last week.
Yeah.
Trying to determine what would happen. My second question is, somebody mentioned a recipe for NASA bombing. With Halloween coming up, would you be willing to share that recipe? Maybe post it on the website?
I think that's a NASA secret. I know they use butyric acid. I don't know if you've ever smelled butyric acid, but it's pretty raunchy. It'll almost make you heave. But I don't think they're going to share the recipe.
With a shot.
So I just wanted to thank all our speakers for coming out and answering questions even beyond your level of expertise. And I want to thank everybody here for coming out. I appreciate your time. Please feel free to visit the booths if you haven't. Some of the booth people were up here talking, so I know you didn't get to actually interact with them. We do have to be out of here by about 3:15, so if you could visit booths, and thank you. If you have more questions, the website is robotics.nasa.gov, and it's also posted on the walls everywhere. So please go there, you could ask questions, and we'll find subject matter experts across NASA, not just at WSIP, that can answer your questions.